Hi again everyone. We are now going to start with the key concept in all programming and even our lives, and that is decision making. Everything we do in our everyday life involves some kind of a decision, from something as simple as choosing what to eat for breakfast to choosing what you want to study in college. Now, we make those decisions based on a lot of conditions that we consider. Depending on those conditions, we choose if we want to do this or that. So, if I'm not too hungry, I will eat a banana. But if I am, I will have some eggs. Seems kinda simple, but it's the basics of any decision. We first evaluate a condition, and then, depending on what the output of that condition is, we make our decision. This concept is what drives the majority of all codes around the planet. Conditional statements and decision making in Python is what we will be covering today. To understand the flow of conditional statements, or what's also known as if-else conditions, let's take a look at this diagram. In very general terms, let's look at a scenario where you are applying for college. The condition that we are evaluating in this diagram is, are you interested in computer software or in computer hardware? If you are interested in software, you will take the action, fill in an application for computer science. But if you are interested in hardware, you will take the action of fill in an application for computer engineering. Then you will continue and submit your application. This is a simple form of the if statement. Let's look at how to implement something like this in Python. Let's say we have a variable called word, and we want to print it if it has the word hello. The code will look like this. Most of the programming languages like C, C++, or Java use braces to define a block of code. Python, however, uses indentation, which refers to the spaces at the beginning of a code line. In the previous example, the spaces before the code print word is mandatory, and it defines the action if the previous statement is true. In our college example, we did not account for if you are not interested in either of the choices. What would you do then? To cover this, we can include an action for any other input that was not in the options. Our diagram becomes like this. The else has to come after an if statement, and it will cover all other possibilities that were not included in the if statement. In our code, if the word is not hello, the program will do nothing. Let's add an else statement and observe the changes. What would be the output for the following codes? You can pause the video and try to guess the answer. With those couple of examples, we now have a general idea how if-else structures work. Now let's get into more details. Python offers relational operators to compare the values of variables. These operators are equals, not equals, less than or equal to, greater than or equal to. Python also has Boolean operators to combine more than one conditional statements together. These logical operators are AND, which return true if both statements are true, OR, which returns true if one of the statements is true. NOT reverse the result, so it returns false if the result is true. Let's look at a new example. We have a variable called number, and we want to check if this is a positive number and is less than or equal to 1000. You can pause the video and try to code it. As you can see, in the above example, if the condition evaluates both statements, the first one, number greater than or equal to 0, returns the value false, and the second one, number less than or equal to 1000, returns the value true. But because they are linked with an AND operator, all the statements have to be true for the entire if condition to return true and execute the print command, the number is in the range. On the other hand, the OR operator needs only one of the statements to be true for the entire if condition to return true. This applies to as many statements as you need to include. Let's take another example and try to detect if there are any problems with it or if we can improve it to become more efficient. This simple code checks a variable word for 4 sentences. The issue here, when the code finds which sentence it is, it does not stop checking, and those checks are redundant as we already found the sentence and we know that all other checks will return false. This means we are using computing resources and time inefficiently. And this is critical for big applications and codes that you might encounter in your next advanced courses. To counter this, we use elif, which is short for else if. This means that only check the next condition if the current one returned false. elif is also critical in evaluating another condition after an if statement, as it does not just execute whatever under the elif, it checks again for a new condition, then it executes. When we modify our code, it will ignore all the following if statements after the one that finds the sentence as it chose. Let's now practice those concepts in a small challenge. Create 2 variables called length and width and write a code to print those variables if either the length or the width fall in the range of 1 to 100. Otherwise, let your code print none of the variables are in range. Before moving into more advanced techniques with if and else, we will look at one more detail: Boolean variables. Boolean variables are variables that hold either true or false only. Sometimes we refer to them as 1 or 0. We can use if and else statements to directly check their value. Check this example. The statement if flag means that if the variable flag is true or has a value 1. To check if the variable is not true or has the value 0, we use the reserved word not as it chose. The statement if not flag will return true only when the flag is 0, as not 0 is equal to 1. We will cover more examples and exercises where we can practice those concepts further in the next video.